Welcome back. In this lesson, we are going to talk about integrating our application so that whenever we fire our Stripe payment, we actually will see it in our dashboard. Now, if you remember from a couple lessons ago, actually it's been quite some time, when we built our Stripe integration into our application, all we were doing was leveraging the front end, but we were not actually adding anything into our actual backend because we needed to actually integrate with some kind of server to create the payments after going through the checkout flow. So in this section, we are going to take a deep look into what it's like to actually complete a full Stripe integration. Now, you might be wondering, why is it that we need a backend server, and then what is a backend server? Well, I'm going to answer all those questions for you in this section of the course. And of course, this will definitely cover some backend. Now, I'm going to try and not go too deep into it because backend is a lot of things that we have to talk about. And quite frankly, you don't need to know everything in order to do a React application. In fact, you don't really need to know that much backend at all to build React. But for the sake of this Stripe integration, I'm going to have to at least explain it so that it makes the most sense without going into a 3-hour lesson on writing Node backend code. Now, let's cover the first question about why Stripe needs a backend service. Well, you remember how when we went to our Developers tab, we were able to access either one of two keys inside of our API keys. There was the publishable key and then the secret key. The publishable key is our way of telling our Stripe libraries that we use on the front end which account is trying to make the payments. So it's part of their authentication process. The secret key, however, is what they store secretly for us on our backend server. And because it's hidden on our backend server as an environment variable, other users are not able to intercept that key when we're making payments through our front-end application. If people were to get access to your secret key, they would be able to technically make payments on our behalf or take things out with the secret key. They can also steal or intercept people's Stripe payments when they're in the middle of being sent to our backend. Either way, the secret key you absolutely have to hide from anybody that might be able to access it on the front end. And the big issue is that there is nothing you can truly hide on the front end. You absolutely must keep anything related that you want to hide on the back end. And that's the main reason why Stripe requires us to create our payments through a backend server. Because the backend server takes requests and sends it out. But except for us, most people are not able to actually access the backend. So we're going to actually take this secret key and we are going to hide it inside of our backend, and I'll show you how we do that when we actually start writing our backend. But that's the idea behind the secret key. Now, let's actually talk about how writing our backend server is going to work. So we are going to write it in Node. But what is Node? Well, Node is actually an environment that allows us to run JavaScript outside of the browser. As we know, we run and write HTML, CSS, and JavaScript because those are the languages that our browsers are capable of parsing. Well, it turns out that there is another environment that is able to run JavaScript code outside of the browser, and that is the Node environment. So what we end up writing is actually Node code, which is JavaScript. But it's orientated around the idea of writing backend code. But in order for us to demystify this, let's take a look at how the environment has changed ever since the introduction of single-page applications. Because through single-page applications, we kind of disconnected ourselves a little bit more from understanding how web applications used to function before, between the front end and the back end. So in this diagram, I've demonstrated what an older version of web development looked like, as well as how web pages might have worked before we had single-page applications. Now, imagine we had some backend server that was serving to us our code for the pages that we are trying to browse to inside of our web application. Now, if you remember and have used web applications before in the early 2000s or in the 1990s, you'll remember that pages loaded slowly and it almost looked like pages were always refreshing whenever you were navigating between them. Well, this is because this is actually what was exactly happening. What we would do from our web application is we would make some kind of request to an endpoint, very similar to the URLs that we're used to routing to now. A server would expose those to us, and our client, so our web application, would make a request to that endpoint, say home, for example, and it would try and get some piece of data from that homepage or that home route. Our backend server would then send back all of the HTML, CSS, and JavaScript that was related to this homepage. And we would do this through the REST parameter. So what REST stands for is Representational State Transfer. And it's pretty much the basis of how we are able to get, post, update, and delete data from our client to our servers. And the main point behind this is that we used to have to write our front end with anticipation that we were going to be fetching all of our pages related to our front end application from our back end with every single route that we're trying to hit. Now, how React works now is that we simply hit one route, maybe just the base route. The moment our client requests from our server, right, that I've landed on your application, our web server will send over one big bundle of HTML, CSS, and JavaScript. And the client will then process all of these pages inside of the client, which is what exactly the React library is doing. It's leveraging JavaScript to build out the appropriate HTML and CSS files at each route. It no longer needs to go to our server and request the data, so the HTML, CSS, and JS files related to the pages that we're trying to hit. That's why we use tools like React Router, and we use tools like React, React DOM, right? Including our CSS and JS libraries that we've now used. We use all of these tools to leverage more and more of our front-end client, so our browser's JavaScript capabilities, to build out all of these pages that we used to have to request for. The problem with this is that we still need the backend server to hold our data, which is why we use tools like Firestore and Google Firebase to handle a lot of things that we cannot do on the front end, because we either don't have the capability to store all that data, or if we want to hide things, because as I mentioned with our secret key, there's a lot of environment variables that you do not want to expose on the front end, because the front end can always be attacked in between these requests. So with secret keys and things like that, you want to keep on the backend server. Now, we will talk about REST a little bit more a little later, but one big thing for us to keep in mind about building this backend is going to be the fact that while we do get all of our front-end application the way that we've been doing before, we're still going to make a request to our backend server, and we're still going to get the bundle. We might want to make requests so that our server does certain things. And this is typically handled through some kind of API. Now, what is an API? Well, API stands for an Application Programming Interface. And it sounds fancy, but it's pretty much exactly what we're looking at. It is different URLs, right, or endpoints that get exposed from the server that we are able to make requests to. And we've actually done this numerous times already. We did this when we were playing with our JSON placeholder, right? Whenever we made a fetch request to a certain URL. That was what we were doing, is we were hitting an API that had exposed that endpoint to us that gave us specific data. In a similar way, these backend APIs are also able to expose an endpoint that instead gets a post request. And a post request is us sending data over to that endpoint, asking it to do something for us. So if we go over here, we'll actually see a more likely kind of API that we'll see. You'll notice that it looks almost identical to what we were looking at before. Except the difference now is that maybe, let's say we had some kind of blogging application with a blogging backend server. When we want users data, or if we wanted things related to users, we make a GET request to this user's endpoint, and we get back some user data. Very similar to what we do with Firestore. We are making requests, except instead of not going to an endpoint, we use the libraries tools that they provide for us to get our users. Similarly, let's say we were requesting posts from a user ID. We would have to hit a different new endpoint, pass in the user ID as a parameter, and then this backend server would then give us back the post data based on that user ID that we're requesting from this endpoint. The same thing would work for a posts on comments on a specific post. But the structure is pretty much just that. We have the server that shows us these routes, these endpoint routes that we make either GET requests or POST requests or update requests or delete requests to, send it some data or maybe no data at all. And then the code on the backend server will determine what to do with each of those requests at that specific endpoint. So that's pretty much all Node does from a conceptual high level. How we actually write that code, we will see in the next lesson. I just want you to keep in mind that this is the main thing that we're doing when it comes to building a backend, as well as how the backend integrates with the front end.